Hello, my name is Parastu Porhonan. This is a presentation about my dissertation utilizing humanoid robotic for sign language tutor. What's the sign language? Sign language is a system of communication for people who cannot hear. So they use their hands, fingers, and movements to communicate with people. As decoded by Migdari in his study in 2019, more than 5% of the world's population are deaf or have hearing impairments. So this makes up an around number of the 316 million people. So this is a great number. And according to data released by the British Sign Language is becoming important in the UK with the increasing number of deaf and verbally challenged individuals. So in the UK alone, the number of people with hearing impairment is around to be 12 million adults, and around 50,000 children are suffering from the same. So this group of the people in society depends on sign language as a means of their communication. Also, according to Koze Yorganucci and Itayuma in 2011 again, sign language involves a combination of letters, words, and phrases illustrated by the hand. So hand movements in sign language create visual output for deaf people. Sign language has improved learning accessibility and efficiency for deaf people. So in many countries, sign language is the specific language learned by deaf people. According to National Institute on Deafness and Other Communication Disorders, there are 300 distinct sign languages across the world, and 98% of deaf people do not receive education in their sign language, and 72% of families do not sign with their deaf children. 70% of deaf people don't work or are unemployed. 1 in 4 deaf people has left a job due to the discrimination, and 1 of 4 deaf women will be sexually assaulted in their lifetimes compared to 1 in 10 hearing women. 9 out of 10 children who are born deaf are born to parents who hear, which has also pushed the call for early education of sign language. Based on the report, there is a need for an effective solution to help solve the communication barrier between adults and children in this category. The project is aimed to utilize humanoid robots for sign language tutoring. Humanoid robot Nao V6 as a subject is proposed to design the sign language tutoring program for sign language learners, especially children. This will be accomplished by designing an interaction learning focused on visual communication, turn-taking, imitation, and developing specifically for robots and learners to take part and give children a splendid chance to learn and quickly apply their new sign. The project is secondary research where a systematic and critical literature review is conducted to input the design. The Scopus article database is used to review and analyze existing data on educational robots and sign language. Sign language in robot hand gesture recognition. The expected result is an automated program that can improve the robot-child interaction and provide safer sign language tutoring in such times as the COVID-19 pandemic, where social distancing has taken place. There are various limitations to the program project, such as Nao Robot only has 3 fingers. If we could add the gestures. This project investigated the concept of sign language execution with the aid of human robots. Generally, people, especially children, have short attention limits and can usually become overstimulated during learning of subject as words as sign language. Furthermore, we live in an age where robotics are becoming a regular part of our daily lives. So hence using robotic hands to teach the children will not only improve their enthusiasm towards learning the subject, but will also reduce overstimulation in classroom. To do so, we first build a classification model to identify the sign alphabet using CNN, and then for real-time application, the hand gesture sign is detected using OpenCV and fed to the model to make the final prediction. And after recognition, for further use of human robot, now visual recognition. Our research methodology was in-depth review involving both a systematic and critical literature review, and applying the humanoid robot Nao V6 robot in sign language tutoring reported by various authors in one phase. The review considered CACOD and Charcog technology of using real-time gesture in configuring hand signals for robotics. So other sources such as Carl Yoragani and Itama in 2011 created the stands for software analysis and proved to operate the humanoid robot. There were other concepts and arguments that proved that the technology that back up the human robot concept presently discussed. And electric search was conducted on a Scopus database, which contains a variety of sources from various publishers. The decision to use Scopus for investigation was due to the high ranking and wide citation, and it is major world universities with the outside and inside of the UK. Secondly, in comparison to other digital databases like Google Scholar, it can analyze and provide results. From 15 February 2017 to 15 March 2021, a combination of a small set of keywords to find the overall research landscape and robotics in sign language technology and education, as well as interdisciplinary research, engineering, computer science, medicine, mathematics, neuroscience, and health and social science was the keyword. Keywords such as sign language robots, humanoid robot, now V7, V6, and educational robots were also used to find the most relevant articles and book chapters. The search was done in 2 steps. The first search considered finding relevant articles about educational sign language robots and sign language and robots in sign language tutoring. The second search was aimed at finding articles on the application of humanoid robots and the application in sign language tutoring over the past years. The first search relieved 15 articles, and of which, after filtering, only 16 articles were selected for the study. The second relieved 20 articles, of which, after a Scopus filter tool, only 8 articles were relevant to the project. The research results were articles from several publishers and venues such as IEEE and International Conference on Humanoid Robots, and the obtained source were then analyzed, and the obtained results are discussed below. The purpose is and analyzed in the methodology chart below. The following slide is part of the history and international profile of our publication on ASL robotics, and the second phase is about humanoid robot application in sign language education. Here you will see a sample of the taxonomy for robotic in sign language and robotics technologies in sign language. This is the structure and deep survey about the sign language. It considered most of the features, for example, deep application complexity and database and sign languages, input modality and features, fusion, and some other features. We find some similar researchers like this one, Humanoid Robot Assisted Interactive Turkish Sign Language Tutoring Game, which was studied in Turkey in 2011, and they used this Nao Robot to learn some Turkish words. As you see, their study followed by another study about a new robotic platform for sign language tutoring, humanoid robots as assistive game companion for teaching sign language in 2015. Basically, it was evaluation of the robot sign language tutoring, and they used vision and video-based robot to assist the teacher. As you will see in a picture, the robots assist the teacher, do the same gestures and the words. Basically, it's a limited work, around 14 words to teach in schools. Another work done in Iran in teaching Persian Sign Language to a social robots via the learning from demonstration approach. It was done by the Hosseini Sayyed Tahiri and Ali Rezan Miqdari, Ali and Alamani and other colleagues in 2019. So this is basically a recent approach of the using humanoid robot in teaching or assisting sign language teaching. This one is another sample. They designed and created a hand robot with 5 fingers to simulate the human hands and gestures, figuring out the rendering and differences of the hands between humans and robots. As we discussed earlier, we will use data modeling to classify our data, and this is the basic structure of the building the classifier model and building the interface. In order to make our system, we will use lots of libraries and tools. These are some summary of the tools and softwares we will use to train our model or build our interface. As you will see, this is the visual example of our training and validation accuracy and testing accuracy and our the loss. For the result of our modeling and training using 3-layer CNN, we could manage to train our dataset, which was the MINIST dataset from Kaggle. That was the picture 28 to 28 pixels, and the accuracy of our training was around 95%, over 95%, and the test result was at the first step was 94% and 70%, but we by just adding some other features, for example improving our APEC to 20, we could manage to improve it to 100%. The third step is to make the interface that will interpret the sign language. This will be made using OpenCV library of Python. The image will be captured and will be made ready so that it can be fed to the CNN model, and the output of the model will be displayed in the screen. This is the results for our trained model. The interface that we created for our trained model. In order to developing our vision algorithm on Nao Robot, the process was include image processing, retrieval an image in the Python board from Now camera, process the image, integration in the complete behavioral in Choreograph, box and subbox, tuning the right head position, using video monitor, installing a timeout. In conclusion, the system can be used in medical, educational, and many other fields. We will be very happy if the system comes in use of society and people. In the next version, we will try to make the system more accurate and stable than this version, and we will try to add more features like recognizing more kind of hand or face gestures and other ASL words, not just alphabets. Thank you for listening to my presentation. I hope you will enjoy the topic as I enjoyed to finish that, and see you soon.